Our third lecture video on work, power, and energy will cover the topic of power. By definition, power is simply the rate of doing work. To calculate power P, we will take the amount of work W divided by the time T. If no work is done, then no power is created. Before we take a look at the units we will be using for power, work, and time, let's look conceptually at power. If we have someone applying a force to a cart to move it, work is being done. If they push the cart slower, the time it takes to move it a certain distance will be longer. This will create less power. However, if the same person pushes the same cart the same distance, but they push it faster, the time it takes to move the cart will be shorter, so more power will be created. It is important to note that in both situations, the same amount of work is accomplished because the same force is being applied and the cart moves the same distance. Now that we know what power is and how to calculate it, we need to discuss the units for power. In the SI or metric system, power is equal to work divided by time, and work is equal to a force times a displacement. If we look at units for force, it is measured in newtons and displacement is measured in meters. Time in the denominator is measured in seconds. 1 Newton meter is equal to 1 joule, so power is measured in joules per second. This is the same thing as 1 watt. However, power is often expressed in kilowatts or megawatts instead of just watts. The conversion that 1,000 watts is equal to 1 kilowatt and 1 million watts is equal to 1 megawatt are both conversions that might help make our answers make more sense, especially when we're talking about a lot of power. If we are in the English or standard system, power is still work divided by time, and work is still a force times displacement. However, force is measured in pounds and displacement is measured in feet, so power is measured in foot-pounds per second. Most of the time when we are talking about power in English units, we use the term horsepower. 1 horsepower is equal to 550 foot-pounds per second, which is the same thing as 33,000 foot-pounds per minute. Another way that we can look at these units is that 1 horsepower is equivalent to moving a force of 550 pounds a distance of 1 foot in 1 second, or moving 1 pound a distance of 550 feet in 1 second. One thing that is worth mentioning is that all of these conversion factors are exact numbers, so none of them count when you are trying to figure out how many significant digits to use in your answer. Let's take a look at one example of a power calculation. The power expended in lifting a 755-pound AC unit to the top of a building 75.0 feet high is 8.00 horsepower. How much time is required to raise the unit? First, we will write down the data given in the problem statement. We know the power exerted is 8.00 horsepower. We know the distance the AC unit moves is 75 feet. The force being applied in this case will be 755 pounds. The reason we use the weight of the AC unit is that we are lifting the AC unit vertically, and since we are assuming the AC unit is moving at a steady velocity with no acceleration, the AC unit is in equilibrium in the vertical direction. Since it is in equilibrium, that means that the weight force of the AC unit has to equal any forces in the opposite direction, which would be the force that is being used to lift the AC unit. The idea that the weight force is equal to the force being applied to the object is true for any motion in the vertical direction with no acceleration. Going back to this problem, we are trying to calculate the time it takes to raise the AC unit. In this problem, we can use the power equation as our basic equation. Power is equal to work divided by time, but since we aren't specifically given work, we can use the substitution that work is equal to a force times displacement. Therefore, power is equal to the force times displacement divided by time. In order to get our working equation, we will multiply both sides by time t, and then divide both sides by power p. This gives us a working equation of time equals force times displacement divided by power. Next, we can substitute in the pieces of data we were given. Time equals the force, which is 755 pounds, times the displacement, which is 75.0 feet, divided by the power, which is 8.00 horsepower. However, this will give us units of pound-feet per horsepower, which is not exactly what we want for time. We don't want horsepower anywhere in the answer, so we will need to use the conversion factor that 1 horsepower is equal to 550 foot-pounds per second. Multiplying by this conversion factor will remove the horsepower. We can also cancel off foot-pounds divided by foot-pounds. This will give us units of 1/1 seconds, which is actually just seconds. Time should be measured in seconds, so this conversion makes sense. Dividing, we see that the time is equal to 12.9 seconds. This concludes our first lecture and example on power. The next lecture video will cover a couple more power calculations.